Collins Maths Frameworking, book 3.3, 9.3, exercise 9C, multiplying with numbers in standard form. So I've got two numbers here in standard form, and we're going to multiply them together. Before we do it kind of the way we're supposed to, let's do it longhand and kind of see where we're going to go with this. So 4 times 10 to the 3, that's 4,000 times 1.5 times 10 to the 4, so that's times 15000. Yeah, equals, and I need to get myself a calculator. Okay, got myself a calculator. Now, hopefully you don't actually need a calculator. You can perhaps do it in your head, but some of you might want that reassurance. So if I was to do 4,000 times 15,000. Now before I press equals, let's just think about this in our heads. Let's do the 4 times 15. 4 times 15 would be 60. And then we put all the zeros on. So I've got 3 zeros here and 3 zeros here. 2, 3, 4, 5, 6. So that'll be 60 million. Oh yeah, absolutely. Okay, it's always good to try and do it in your head first. So we end up with 60 million, which would be, in standard form, 6 times 10 to the 3, 7. Okay, now let's look at how we might do it here. So, now we need to be careful here. 4 times 1.5. Okay, so again, I could use my calculator, but well, 1 4 is 4. Another half of that, half of 4 is 2. That would be 6, wouldn't it? 6 times, and then what we do is we add up the powers. Can you see the link here? 6 times 10 to the 7, 4 and 3 here, times 10 to the 7. So basically the rule is when you multiply the numbers and then add the powers. But, take care, because, let me do a different example. 5, is that correct? I can't see from there. Minus, yeah. Okay. So 2.5 times 6. Again, I can actually do that in my head. So 2 6s are 12. Half of 6 is 3. So that would be 15 times 10 to the, so minus 3 plus 5 is 2. But here's where we have to take care. Because we've gone over 10, that's not really standard form. So we need to kind of just adjust that slightly. So 1.5. Now, do we increase the number or do we decrease the number? Well, we're moving the decimal place this way. We're making the number smaller. So to correct it, we need to make this bigger. Does that make sense? By moving the decimal place this way, we've made this number smaller. So to make the number correct again, we've made that smaller, so we have to make this number bigger. Let me do one more example, example C. So we need 3.5 times 6.4. 22.4 times 10 to the, okay, so minus 3 plus minus 4. Be careful, minus 3 plus minus 4. Well, when you have these two symbols different, they become minus. So it's minus 3 minus 4, which would be minus 7. Equals, that's not standard form because it's more than 10. So it's 2.24 times 10 to the, right, what are we going to do here? We've made this number even smaller, remember? So we've made that smaller. So to compensate, this has to go bigger. So we divided that by 10. So this needs to be in times 10 more. Well, that's minus 7, so we need to go to minus 6. So we made that number smaller. We've made this number bigger by a factor of 10. Okay, and of course, because it's negative, bigger means the number comes, minus 6 is bigger than minus 7. Okay, whew. Hopefully that's clear. That is a little bit of a confusing one, but the basic concept is you multiply these numbers and then you add the powers.